Hello everyone, this is Jahnavi Pachala. My teammates are Rasi, Sabarish and Manoj Kumar. We are students from University of Houston. Now we are discussing about our Big Data Analytics project where we used BCA to reduce the dimension and logical regression to find the accuracy. And later we had to compare the accuracy using some classification models. So here we taken decision tree to compare the accuracy. And we also taken our sample data set, which is a cancer data set. Here we have 100k rows. So here we predict whether the person is having cancer or not using the 0 and 1's column. If the person is having 0, then he is not having cancer. If it is 1, then he is suffering with cancer. So here we built a code for this a data set. Uh, there is yeah. Here we imported some libraries like pandas, numpy, and math. Later we read the cancer data which we taken for sample, and later we chosen 5 data rows. And we used sklearn here, sklearn library, because we want to scale the data, all the columns. So to get that data frame, we used sklearn preprocessing to get this min max scalar. And later we used gamma. We found gamma using this 4 and 4. Uh, we get this gamma here, gamma matrix, and you can look at the difference between the previous data we had and the data right now after doing the gamma matrix. The next, we taken matplot library to give visualization of a data set. Uh, it gives a correlation using heat map, which shows us the magnitude of phenomena as in color of 2 dimensions. Here it is like we will take the range which is having 0.7 to minus 0. I mean minus 0.7 to 0.7 range. Whatever the columns or higher than this will be eliminated manually by us. After taking this correlation, we we drop the sum of these columns because it is not required for us. So then after we imported time uh, package, and from there we taken time package to look over the accuracies. So here of doing logical regression, we taken library linear. Linear is used we because we have only max and min values. So it is a linear graph we are going to get. So we choose a linear library here, and here x is x. This column takes all the rows except the last one, and this y column takes all the only last row. And then we have taken this test and train split. Here we given size 0.1, sorry, 3. Here that means the test it is of 30%. The training is 70%. We give training to the system 70%, and then we test it to 30%. So here taking the start time, and we taken we taken the net time after running the X train and Y train. After training the machine, we taken the net time, which gives the a difference of I mean how much time it is taken to run to train a system. So after getting it, you will get the net score, and from there we choose a random forest classifier for decision tree to get the accuracies. So here we taken training set, and we used accuracy score function. Then we got the accuracy as 1.2. This is a manual work we have done up to now. So you have eliminated these columns by just looking at it manually after getting your heat after you generating your heat map. But if you use your PCA, then you need not to use your visualization thing and all the manual work. You can directly get the system directly can do the work using the PCA. So now here the PCA will take all the required columns and remove the remaining columns and gives you the clear data. From there, you can uh, you can look at the shape, like this shape method sorry, shape function gives you the number of rows it is having. Like you have 144. So and you have 10 columns. That that's how the shape gives you the output. And here thereafter we taken the uh, new difference and the before one, and we concatenated both of them, and then we used a logical regression directly, uh, and we taken the same thing as we did before, x and y. From then we given test and train to the system. You get the start type, and you have this logical regression. You take all the data train set and y train set into here, and the regression will happen, and it gives you this accuracy score. After you getting the accuracy score, you just need to uh, use the decision tree to compare these accuracies. So you already given the accuracy for you already got the accuracy. Now you are feeding that accuracy and predicting whether you were testing the data. Now you already trained the machine, now you're testing the machine. Now you'll get the exact accuracy score that you predicted and the result. The y testing is what you you really giving, and why predict is we predicting the exact test. So based on the prediction and the real result of testing, it gives you the accuracy score, which is a PCA score, and we're printing here 1.0. That's how this project works. Like the machine learning is like it is train here we are training the whole data set, then mission understanding each and every part of it, and later we are asking data mission to predict whether the person is having cancer or not. So by which your manual work will be reduced. You can do it manually, even though like we generated heat map here and plotting it, and without using this process you can do it using a PCA. So that makes your time reduced, and you get accurate results. So that is all about my project. Like it's really important in our daily lives because we have to get a lot of patients and a lot of data we have been working. This is just a sample set for the cancer and heart disease patients. There were so many of them. So for that, all these things, we use this uh, process like we use PCA, logical regression, and random say decision trees, so that you get the accuracies, and the mission itself prints you whether the person is having cancer or not, by which will become now easy for us. So that's all about our project. Thank you for watching.